Okay, so this question, remember there are two versions of the exam, and I'm picking the one that I think has the slightly more difficult of the two questions so that I can explain the most. Okay, so this question, I want to talk about part B first because it's the easy one. Part B says, what about the overall average speed to the destination? So some people accounted for the turnaround even though I said you didn't have to. But if you do account for the turnaround, that means you give the person credit for walking this extra distance twice more. So the whole distance, instead of being 10, will be 12. And so anybody who made that in either version of the exam, anybody who did that still got full credit. I also did not care whether you made the speed positive or negative. I didn't care about that. So all that doesn't matter. I'm going to just proceed the way I did with those explanations. Anyway, this is your independent variable and this is your dependent variable. So here's your location or your distance, whichever you prefer. Okay, so if you just look at the total distance is equal to 10 and the total time is equal to 8. So it could be 8 hours, 10 miles, okay, whatever units you like, whatever units you want on this. So the total distance over the total time is like 5 over 4, which is 1.25. And again, if you made it 12 over 8, it would be 1.5, plus or minus 1.5, plus or minus 1.25. Those were all acceptable. Okay, so here's the thing. If Alan's speed is 1.25, you can just look at Betty's formula here. This formula is t divided by 2, right? And I've told you that this 1/2 is really like a speed. It controls the speed. That 1/2 is 1.25 times 1/2. Betty is going half the speed of Alan. So whatever that is, you know what? You can go ahead and calculate that. It is a 0.625. Okay. And Chris's overall speed is times 3 versus Alan, so he gets 3.75. So you don't have to do any other work beyond that. That is perfectly acceptable. But let's say you don't know that. You can finish all of part A and then go back and do that based on your graphs, if your graphs are correct. Okay, just erase that to make some space. All right, so I want to make up a list of points that I can use. I want to make up a list of points so that I can do my translations. So my points are 0, 10, 2, 7, 4, 7, turn around, go get this other item, and 8, 0. Okay? And so the information I need is that I want to make this translation and also this translation. What does that mean? What do I do? And so the point is I need to find new t values to put in here so that I get these t values back out. Please note there's no plus d here. There's no multiplier here. So if you go back to the formula from question A, notice this formula. It's the same thing except A is 1 and D is 0. So we don't have to worry about this kind of stretching or any kind of shifting in that direction. Those are irrelevant. We are only focusing on the other aspects of the shifting. We're only focusing on this particular axis, the inputs. So if we want to find, so I'm going to call these, for the sake of argument, I'm going to call them x's so that we can call this one t. So if you say x equals t over 2 plus 5, you can just solve for the other variable. X minus 5 times 2 equals t. And over here, x equals 3t minus 4 means that x plus 4 divided by 3 equals t. So what we can do is we can just make up these tables. And this table, I'm going to call these t's again. And I'm going to just literally, because A meaning that there's no stretching, there's nothing happening on the output side. literally nothing. So I can just paste these guys right in here, and that's typical for these hiking graph problems, like because the people are theoretically hiking on the same plot of land, so the locations have to start and end the same. It's just we're changing the relative speed and the starting time. So the locations are all, they're going to be the same. Okay, so then we're going to just go ahead and take this formula off of these x's and put them into these t's, right? So let's see, x minus 5 is negative 5 times 2 is negative 10, and I'm just going to do the rest of these. Okay, so each of these x's was plugged into here to get those t's. And then we just do the same thing for the other equation. Okay, there we go. And so we have used this formula to get these t values off of these x values. Alright, so now I'm going to just copy these things down into the graph so that we can plot them. And I'm going to pause while I do that. Okay, so this is what your final graph should look like. It looks really weird. I had originally plotted it with A in there, but it was too confusing, so that's why I just asked you to plot B and C together. What you should have gotten was a very squished, narrow C and a very wide B. Some students had the expansion correct, so they had this factor correct, but then they put this piece of plot, for example, they would have put this guy somewhere else, like maybe put it somewhere else. If that kind of thing happened, then you got partial credit for getting the compression right, even though the shift was wrong. So I think most people, once you have these points, don't have any trouble plotting them, so I didn't need to belabor that. Yeah, the students who have had trouble with plotting just have had trouble figuring out which is the x and y axis, but I haven't seen any evidence of that in this class. I think you're all set on that. So hopefully that helps, and good luck studying.